Hey guys, started streaming. Let's see if I'm actually live. Hello. There seems to be a little bit of a lag, but I can't. What is going on here? Yeah, okay, got it. Wait, is the audio lagging? Okay, I don't think it's that bad, I guess, right? Okay, it's not good. It's not bad. What about YouTube? Let's see. If I go to my channel, I'll probably see the YouTube here, right? Yeah, yeah, I'm live. Yeah, okay, it's working. Upload chat. I mean, not that there are people in the chat. I just want to, if anybody pops up, I just want to know. So yeah, today I just kind of want to, be chill and look at some couple of things actually. So yeah, a couple of stuff happened in the last, couple of days. Mainly one is that Llama CPP just merged the MTP PR. So what exactly is MTP? Well, let's find out. What is the difference between MTP? MTP is pretty much a new version of speculative decoding. So let's see. What is first of all? Explore what is speculative decoding? Decoding. Let's see. So in the meantime, like I told you, right? The Llama Llama CPP got Llama CPP merged the MTP PR. So I was like in the background, compiling it and building it to the server, so we can try out MTP. And one thing that I want to try out is like the I usually run the Onslaught quantized models, and the favorite model that I run in my setup right now is Qwen 3.6 35B A3V. It is like the best local model that you can run right now. So pretty much like the smartest local model, if you have like a decent ish like a PC. My setup is like a 12 GB VRAM 4070 with like 32 gigs of DDR5 with I think it was uh 13th gen Intel i5 13600K, which is a very capable CPU. But like 4070 is good enough to run like pretty good uh models. In this case, I'm able to run the Qwen 3.6 35BA3B, which is like a mixture of expert model and pretty good actually. Well, there are similarities between like the mixture of experts and as well as MTP, but like it's vastly, but still it's like vastly different. The A3B here significa bruh. The A3B here significa is what the hell? The A3B here signifies that it's a mixture of expert model. So basically, A3B means active 3 billion parameters. So 35B is the total parameters, and A3B is active parameters. So 3 billion active parameters. Now, basically, in case of like what exactly is mixture of expert, I've covered it in the previous live stream, but yeah, in short, mixture of expert is basically like having multiple different smaller models joined into one big large model. So each of these smaller models will be like experts on different domains, and sort of like they can collaborate and like work into producing a unified output. So there will be like a centralized router model which routes the input into the different like submodels, and all these submodels, like in case if I am asking like a math question, only the experts that are trained on math and experts that are trained on logic need to be activated. Other experts who may be like proficient in medical science or who may be proficient in like chemistry or something did not like does not need to be activated. So at a time maybe like two or three experts are activated. So in this case like A3B, it's probably like one or two like dedicated expert models. So yeah, that's how a mixture of expert works. So in this case you can like offload just the activated parameters into the GPU and keep rest of it in the disk or the like system memory. So this will like this will provide you with like the quality of a 35 billion dense model without using that much VRAM. So like active 3 billion parameter will probably use maybe like 6-7 gigabytes of memory with like context on top of that. So yeah, it can like run on decent CPU. I've seen like people running this exact model on like 1080 Ti, which is like 7-8 years old like graphics card at this point. So that is like crazy. And it has like 6 gigabytes of VRAM in like 2017 or something like that. So yeah, it is like a 6 years old graphics card and still capable of running like the state of the art open source local models. So that's why mixture of expert is like really powerful. So what exactly is MTP? So first of all, we need to know like what exactly is speculative decoding. So yeah, I've covered this in the previous live stream, but yeah, in short, speculative decoding is basically like having a large dense model and then having a smaller model, and the theory behind it is like some things are like easier to predict. So in the background, LLMs are basically like text prediction engines. It is like very good at predicting what next word comes after like a sentence. So in this case, like it will be like a collection of tokens, and it predicts what comes after the next, like the current token. So it basically predicts the next token. So in the case like some tokens are very easier to predict than other tokens, which means like the probability of getting a token might be greater than the next token. So, which in this case, so it will be like very easy to predict. For example, like the value of pi. Everybody knows the pi value is like 3.14. So if I have a sentence is like the value of pi is, and 3.14 is pretty much 100% like sure. So it doesn't have to compute that much to get to the output of 3.14. It will be like very instantaneous, and that way anything predictable becomes like easy to, yeah, anything predictable becomes easy to predict. So like logical things like coding or like logical stuff like mathematical equations and stuff like that. It is like pretty much only there are like a very few outputs that you can basically predict. So the easier it is to make a prediction, the faster it can predict. So speculative decoding uses this theory to speed up your prediction or speed up your text generation. So it has like a one big dense model and basically like keeps, let's say, a smaller very small model of the same family. So I would say like speculative decoding. mm, yeah, this basically looks like a good example of a speculative decoding diagram. Yeah, this looks pretty good actually. Yeah. So yeah, in the case of like a speculative decoding approach, you probably have like a large, dense model and a smaller draft model of the same family. So in by family, I mean it would have like a same like token pattern or like same decoding setup or same encoding setup. So it will be like uh compatible with each other. So yeah, in the case like if I tell you an example, it would be like something like Quen 3.5 27B, which is like a very dense model, and the draft model you will probably be using like Quen like 2B version, or like even point 0.8 billion version. Even that works like pretty well. So basically, what it does is like the smaller model makes predictions, and the faster model like verifies it and accepts it. So the draft model would be faster in generating or like looking ahead. So pretty much like the draft model would be like predicting exactly what well like the draft model would make like easy predictions. So if it's in case of like anything logical, it would be like very fast to predict something, and the like that would be like easier to just verify for the larger model without actually generating tokens itself. So in this case, like the draft model just predicts, this the dense model just accepts and it like generates further. So that way, you can save a lot of compute, or you can use the same compute to speed up the generation. So that's pretty much what speculative decoding is. Speculative decoding is a pretty like it's not something new. It's been around since like couple of years at least like 2 or 3 years. But like it's a very powerful approach that is still in use today to speed up generation. All you have to do is like have a smaller model and a big model, and like you can plug it. You just have to make sure that it is in the same family, and also you have like a unified model where people like merge the larger model with the smaller model, so you can like graft together these neural networks to create like one big model with two models inside, basically like a mixture of experts. But in this case, you have like a big model and small model used for speculative decoding. And multi-token prediction is pretty similar actually. Like let's see, multi-token prediction. Okay, I forgot about that. When was the paper introduced? Yeah, the V2 version of speculative decoding. Yeah, Google introduced speculative decoding in 18th May, like 2023, the mid of 2023. So it's actually a couple of years old. It is like not something that is like super new. Speculative decoding has been around for like a couple of years from like 2023, produced by Google. Pretty cool actually. It's and not everybody uses it, but like it's actually pretty cool when you think about it. Yeah, multi token prediction is you could think multi token prediction as the next step of speculative decoding. So speculative decoding usually like thinks ahead one token at a time. So the drafter model predicts one token, and the verifier model, the main dense model, would like verify the one token, and and the drafter model moves to the next token. The verifier verifies it, then it moves to the next token, and it goes one token at a time. MTP, on the other hand, it generates like couple of tokens ahead. So the drafter model would like think maybe like at like two, three, four, or even like up to 10 tokens ahead, and the verifier has to verify it. So on verification, it doesn't just verify one token; it verifies the entire sequence. So once verified, it accepts the entire sequence. That's why it makes so fast. If the dense model is if the drafter model is able to correctly predict like multiple 5 or 10 tokens ahead, and it happens to be correct, you essentially like sped up the you essentially spread up the generation by like 10 tokens. So that is like ridiculously fast because the smaller model is very like efficient and very fast. This doesn't work in every single scenario because like if you think about like creative writing, in creative writing from one token to the next token there will be like a very large difference. For example, if I'm like writing a story, nobody really knows like how the story goes, so the model has to like predict the next token, which is not so obvious. Like maybe the story is about like Star Wars. Maybe like Luke Skywalker was not a villain, or like I mean, yeah, maybe the story is about like Star Wars. Maybe it's like like a well-known story, so it can like predict it easily. But maybe it's a very new story, so it might not have it inside its knowledge, so it might not be like easy to predict. So MTP is not the best tool for creative writing, but in terms of like code is like very predictable. For example, like a for loop in Python can only be written in like couple of ways. That's all you can do. You cannot write like for loop in Python like the way it's written in something like C or like something like Java. Python has one syntax, and that is what it is. So it is like very predictable. So MTP works very well for coding tasks, not so well with creative writing. So like let's have a test, I guess. Like let's just test it out. Yeah, I've built the Llama CPP version of MTP, and honestly, it's like not that bad. Uh, what am I saying? Yeah, let's see how like MTP is run. Let's see. Turbo CPP. Yeah, this is how it runs. Yeah, this is the thing. Spec type draft MTP spec draft nmax 6. This is how you run. I don't know if it's. Mm, yeah, let's. I have a couple of like saved queries that I like go to. Let's just look at that, I guess. Or the tool dev tools. Okay. Llama CPP commands. Yeah, this is like one of my go-to commands because this is like the repo that supports TurboQuant, and right now, uh, right now the Llama CPP not doesn't like still haven't merged the TurboQuant implementation. I mean, it's alright, but let's open up. Okay, I'll probably remove this and remove these because the Llama doesn't support TurboQuant yet. Then I need to replace the mmproj thing. It's a build. It requires to remove the. Yeah, that works. Uh, okay. First, let me do the model replacement. Did it download? Yeah, it downloaded. Copy. Let's do without the mmproj because you probably like save a little bit of memory. mmproj is basically like your vision decoder. So yeah, Quen supports vision, like natively supports vision. So if you want vision capabilities, you probably need the mmproj. If you don't, you can like not use that and save some. And these two. Okay. NP. What is NP? Yeah, what NP was. Let's try. Let's see if this even loads. Thing is, like, I'm using 35 gig, like almost 30% of my memory right now. So, like, I'm recoding. So, I don't know if like it can load. Oh, did it load? That was fast. Usually it takes a little bit more time to load and a lot more logs. I don't know. Let me see like how much memory I'm using. Yeah, I'm using like 11 gigs. I have only like 12 gigs, so I'm like barely holding up. Let's see if this actually speeds up the generation. Yeah, it doesn't. Let me first try an article writing so we can go like write an article, write an article about speculative decoding. Okay, 20. I mean, I usually get more than 20 actually. So yeah, yeah, not that great at the moment. I usually gets like more than that. Oh, I'm using like 7.8. Oh, where I have probably like 100 MB of VRAM left. That is crazy. And after that, we'll like try some coding task. Maybe like let's see like how good it is. Because like if it's coding, maybe something like an HTML or like some React application or something, it knows. Like when you open like an opening HTML tag, it knows it has to like close the HTML tag somewhere. So it is easier to predict the closing tag. So it fast speeds up. But in this case, like it's writing, so it doesn't really know, you know, like what words it should be like next. So it slows up significantly. And yeah, I probably think like I'm using like pretty good amount of CPU and VRAM for streaming right now, so probably because of that too. It's like yeah, it started out like 30 something and like dropped to 17. Not the best. I'm just checking if I'm still live. Yeah, still live. Yeah, I'm still live. I don't know why like YouTube, despite on 1080p, YouTube kind of looks pretty muddy, but like Twitch looks actually good. Twitch actually looks good. Anyway, yeah, it's still going on. Yeah, what it is writing is probably good enough, I guess. Like inference bottleneck. I mean, the speculative decoding paper has been around for like long time. In terms of AI time, that is like a lifetime. But yeah, it probably has it in its like training data set. So nothing surprising. It like a 32 like a 35 billion parameter model would probably be able to like write it, but its knowledge is pretty outdated because you would assume it would at least know about Gemma 3. It only knows like Gemma. Oh, it's Gemma 2B. Why is from Microsoft? I don't know what Microsoft is doing. It hasn't come out with like a model in a long time. I don't know what the hell they're doing, but okay. Okay, it dropped down to 16. Started out at like 30 or something. Let's try maybe like an HTML game test. Maybe like let's make a landing page. Gemini. Create create a prompt for for mm, create a prompt for a landing page for a web design company called mm, Agent Spark. Agent Spark minimal style. Minimal style. Glass so more. Create hyper details. Okay, let's see. I think Gemini updated its UI a bit. Wasn't this polished just a while ago? Because I looked at Gemini um like for work today and it wasn't this. I don't remember it being like this nice. Maybe like there are definitely some improvements. The icons here are different for sure. Okay, let's let's just give it to this. Write everything in a single HTML file. Okay, let's see. Okay, it's still dropping. Probably because like, okay, it's now stable at like 28. Yeah, I told you, right? It dropped to like 25 when it was thinking. So like the text part, it dropped to like 25, and now since it's like coding, it is like generating up to like 30 something. It started out at like 26 or something, so it sped up like maybe like 15-20%, which is a considerable improvement actually. Well, this way we can judge its quality, like how good it is. One thing I always want to compare is like how good are the output for like a Q4 quantized version of a model is compared to like the full weights, because like with like 12 GB of VRAM, you are never running like full weights of any model, let alone like the 35B model. Even the like 9B version of Quen with like the full BF16 unquantized is like maybe around like 20 gigabytes, which is huge. Won't be fitting in my 12 GB VRAM. So yeah, I don't know if how well this would perform for like agentic task, because agentic task is not just create like coding, like code writing or anything. You would have to like reason a lot, and there you will like probably be involved in like editing files that are not code, maybe like writing like text documents or something, which will obviously like result in poor performance. So strictly as a coding model, MTP would be like really good, but for everything else, I don't think like for agentic task it would be like that good. But depends. Like it will probably like slow down during the reasoning or like writing part, and speed up during like the tool calling or something, because like tool calling is mostly writing code. Let's see how well this scores. I mean, how well this looks. I kind of want to like merge this to the Turbo Quant repo, like fork of Llama CPP, just so that I can run it like with lower VRAM. Because like 11.7, like 11.8 gigabytes of VRAM is like cutting it too close. It's like too close for comfort. So yeah, probably because now if I just launch maybe like a 4K video, or if I have any like launch a website that is like heavy on graphics, probably like it will probably crash my system running out of VRAM. So I would not want that. I would need at least like 2 gigabytes of free space to like be comfortable. Okay, it's still going on. Oh my god. Yeah, it's now pretty much stable at like 31 tokens per second. 31, like 32 ish. Pretty much like stable. And it's been going on for like 4 minutes. Oh my god. And like 80,000 tokens out. Oof. That, that is insane. Oh. Okay, there's testimonials too. I wish this looks great because like it's took a lot of time. So I wish it looks great. Let's look at like maybe some GitHub trending repositories. OpenHuman, this is like a desktop assistant thing which has like a cute mascot. I've been meaning to run this, but I haven't really like has got the patience to set this up. And I kind of want to like implement this, not implement, like set it up with like local models or something. Also, I have the OpenCode subscription, so that will probably like work well with this. Not sure. CLI anything. What is CLI anything? Oh, okay. You can basically like make any application into a CLI so that like agents can use Bash to run. Okay, that's kind of cool. Blender. Are you serious? Like, can Blender be made into like a strictly CLI application? Oh, do they have like test? Free. Okay, free. They made it into FreeCAD. Okay. They even made Blender. Damn. That is actually pretty cool. I mean, the models look pretty lame, but the fact that it can actually do Blender with just CLI, that is insane. Playing a game. Whoa, that is cool. Video captioner. CLI anything video capture. This is actually really cool. I'll probably like try it out with some. This is this is really cool. Image, GIMP, Inkscape, Credo. Okay. Project management, C clip. No, not sure about what that is. Scientific search, streaming, OBS Studio. Okay. Wait, the command line. That's actually clean. Web browser automation with DOM shell MCP. That's actually really cool. Yeah, comfy UI via CLI. Okay, that's actually cool. Notebook LM CLI. Even that's actually pretty cool. N8N. Damn. Zoom, database, Chroma, debugging, LLDB. What's that? Design, Sketch, Adobe Sketch. Whoa. Okay. DevOps, NS Logger. I know this one. I'm not sure any of the others. Draw.io, Mermaid. Mermaid, do you need like a CLI tool for Mermaid? Like most, I think like Obsidian has Mermaid support. I don't like. Is it that hard to run? What is Mermaid? Isn't Mermaid just like a markup language for diagrams? I don't think it's like that hard to run. What do you need a CLI for that? You can just run it. You can just like edit in Markdown or something. Butterfly game. Oh, Obsidian. But like, do you really need an Obsidian CLI? Because like, pretty much Obsidian is just like a file man, like a glorified file manager with a file opening. All it does is like read Markdown. That is pretty much what Obsidian is. So, do you really need like an Obsidian CLI? But the fact that it can make it into a CLI is the tool. Why didn't I think of like this idea? I mean, I don't think it's like that hard to do, but yeah, probably hard to do. But it is not something super new. The last version is in last month. It is not that like new. You know what happened? Probably some YouTuber made like a video. A second. I'll be back in a second. Yeah, I'm guys. Hey, yeah, I'm back. Yeah, I just had a call with my friend. Is that done? Probably done by now, right? Yeah, it's done. Let's save it into like a HTML and let's see. I'll probably put it into like downloads. G test HTML. Test out HTML. Let's see if this even works. Okay, I will open with Zen browser. Okay, okay, that's actually pretty good. I mean, the animations and everything. That's really clean. Okay, I didn't expect it to be like this. I mean, it's still like generic, but I didn't think like a local 35B model can run and even like generate like such good looking UI. I mean, it still looks generic, yeah, but what with like some design like prompting and like having a design system, you can probably like create like a good project out of it. Now this is the power of of the local models right now. Like really really good. I really like the gradients that I've done. Like yeah, I think okay, this particular gradient is like on top. I think yeah, it's definitely on top. It is not on the background. It's definitely on top. Yeah, even this too. There's like a small gradient here that is also on top. But I think it should be like on the background. I mean, it's not like bad, but usually in glass homomorphism, you probably think like the like foreground elements are transparent and the background element is like faded into like blur. Okay, everything is working. Do these links work? No, okay. And that's pretty much expected. Start a project. Oh, okay, it goes to the mail. Yeah, this is actually fine. You can definitely use like these local models for coding. It won't be solving like the greatest problems of the world, but yeah, you can definitely use these for coding. Yeah. So I mean, it's pretty obvious right now. Like yeah, I got like 30 tokens per second generation speed with like the live stream running. I'm streaming both to Twitch as well as to YouTube and recording the mobile version to my system. So yeah, I'm using like 39% of the CPU with like 30% of the RAM. Yeah, and you're also using the network. So pretty much like maybe like CPU bottlenecked or right now or because like it's because the offloaded parts is in the system memory or even reading from the disk, it has to like write to the VRAM. So yeah, there is like some CPU involved. So yeah, because I'm doing all this stuff, it probably will be a little slow. I don't know how like Llama CPP handles like multi-threading and like multiple core execution. So not sure what's how the technicality works. But yeah, because like every time I'm not live streaming, I like usually observe more uh more like throughput, like tokens per second. Yeah, I mean that's pretty much it. I've been streaming like 1 hour. There's a couple of things that I want to look at. There's like I want to look at like local coding tools, like CLI tools. There are like a few CLI tools you can really look at it in like Termina Bench